Let's take a look at our next rule, the 6-wire rule. This one probably gets violated more than the first, which is our 6-inch rule. There's some simple guidelines that you need to follow when you have more than 6 wires damaged in the harness assembly. First, you're going to have difficulty staggering these splices. The second, you're going to have an increase in EMF, electromagnetic force, the field that's generated around a wire when you start passing current through it. And then finally, something we like to call the meatball effect, when you start stacking splices on top of each other. Well, let's take a look what happens when you have several wires that are all damaged in the same area. Take, for example, this harness assembly. This was crushed in an accident, and clearly more than 6 wires have been damaged in this assembly. So if you want to repair this by any standard, you should be staggering your splices. Well, let's take a look at what happens when you stagger your splices. As you can see, your work area has grown by at least 6 inches. Try to find 6 inches of additional wire in this harness assembly. It's not going to happen. You're going to be tugging and pulling to make these ends meet. So what do you end up with? A meatball. All these splices will be stacked in one area. Well, you wonder, what does it matter? The circuit is fine, it's passing current, that's true. But let's think about what happens when you pass current through a wire. Wire is going to start generating an electromagnetic force, a field around it, when you start passing current through it. Well, when the engineers designed the architecture of this electrical system, they accounted for that. But they didn't account for a splice, or 2, or 3, or 4. What happens? These splices start interfering with each other in the harness assembly, creating a field around them. Let me give you a real-life scenario. We had a customer that was complaining about buzzing or humming in their stereo system. Well, they brought it to the service center, they started looking through the system, and they started replacing radios, started replacing antennas, and finally they got down to the harness assembly. We received that harness assembly and we found a series of splices in it. Once we started going through those circuits to determine which circuits were affected by this type of wire damage, we found none of them had anything to do with the radio system. So we had to stop and pause and think about what was occurring on the harness assembly. And what we found were a stack of splices, a meatball in the harness assembly. So when this customer either turned on their rear defrost or powered up their radio or had any other electrical system on board powered up, the interference from the power and the ground wires started interfering with each other, creating this buzzing or humming in the stereo system. So essentially, the power leads were putting a force, an EMF, onto the ground side of this electrical system, causing a backfeed or humming through the stereo system.